morning, class. How are you all doing today? Today we'll be looking at a very interesting mathematics topic known as Pythagorean theorem. The Pythagorean theorem says that the longest side of the right angle triangle, which is called the hypotenuse, is the square of the sum of the other side of a right angle triangle. So it will look like this. When we have something like this, a right angle triangle. This is actually a right angle triangle. So the longest part, which is this part, is known as the hypotenuse, and this other side is known as the adjacent. This other side is known as the opposite. Okay, so we can label here A, here B, here C. This labeling could be different side. You can choose to label here A. You can choose to label here A, B, and C, whichever way is nice for you. So this part facing this B here can be labeled small letter B. This side facing the adjacent can be labeled small letter A. This side facing the opposite can be labeled small letter C. So in a right angle triangle like this is how a right angle triangle look like. The sum of the hypotenuse is equal to the square. The square of the hypotenuse is equal to the sum of the square of the other side of the right angle triangle, which will give us an equation like this. We have b squared, which is equals to c squared plus a squared. You can say b squared equals to a squared plus c squared. Okay, whichever way you want to do it. Right. So let's add some numbers to these values and see how this theory can give us our needed values. So let's assume this is another right angle triangle, and here is labeled 8. Here is labeled 5. Here is the unknown, which is the opposite. So we are asked to find C, which is unknown, which is the opposite. Remember, here is B, here is C, and here is A. Actually, some people go ahead to use Sokotua in solving sums like this. When you want to solve sums like this, it's not needed for you to use Sokotua. What you should use is Pythagorean's theorem, which is b squared is equal to c squared plus a squared. Yes, correct. So we use that, and then the b squared here we have is 8 squared. So here let's do it here. We have 8 squared, which is equals to the c here is a known, so we have c squared plus a here is 5, which is 5 squared. So now the c is unknown, so we need to make c the subject of the formula. So to make c the subject formula, this 5 squared that has a positive sign, when it crosses the equality sign, it becomes minus. So we have 8 squared minus 5 squared, which is equals to c squared. So 8 squared minus 5 squared will give us, first of all, 8 squared is the same thing as saying 8 times 8, which is equals to 64. And then 5 squared is the same thing as saying 5 times 5. Remember, when we say 5 squared, we don't mean square root of 5. So people go ahead to say square root of 5 or square root of 8. We're looking at square. So square is 8 times 8, and 5 times 5, which will give us 25. So when we have these two values, which is 64 minus 25. Okay, so 4 minus 5, we know it cannot go. So we borrow 1 from here and put it here. Here give us 14. 14 minus 5 will give us 9. So we write 9 here. So here now will now remain 5. 5 minus 2 will give us 3. Okay, so since it gave us 3, we know that this minus this will give us 39, which is equals to c squared. So we need to remove the square here. So we say to remove the square, we say c, because this is still correct. In mathematics, either even if you say 39 is equals to c squared, Here the same thing as saying c squared is equals to 39. So the reverse is still the case. So to remove the square, we can say c is equals to square root of 39, which will give us c, which is equals to square root of 39, which will give us 6.2. So that is our final answer. So if you have any question on this, we would like you to comment. And this is actually the format of solving questions in this order. In the next class, we'll look at solving Pythagorean theory that have that have theta, and the theta is the angle, and in those theta that have angle, you need to use SOHCAHTOA. In the next class, we will look at angles, right angle triangles that have theta in them, and how we can use SOHCAHTOA in solving